We've already seen that cosecant is the reciprocal of sine, and that secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. But it also works the other way. If you know cosecant, you can reciprocal it and get back to sine. That is what brings us to our first three, what are called fundamental identities. And those are the reciprocal identities. You just need to know that cosine and secant are reciprocals of one another. You can flip them upside down and go back and forth between one and the other. Sine and cosecant, same thing. Flip them up and side down, and you can go back and forth between one or the other. So if we look at this first problem right here, if you know cosine of theta is 1/2, well, what is secant? Well, since secant is the reciprocal of cosine, then secant theta is just flip it upside down, 2/1, or the secant of theta is 2. Pretty straightforward. What about, okay, this little funky looking thing? This is an alpha. That's a Greek letter alpha. What if we know the cosecant of alpha is the square root of 12? How could we use that to find sine? Well, remember, cosecant and sine are the upside downs of one another. So sine of alpha, well, let's start with cosecant. Cosecant of alpha, there's a little work to be done here, is the square root of 12. But square root of 12, that's 4 times 3. We can simplify that to 2 square root of 3. And then if we put it over 1, now this looks like a fraction that we can flip over. Remember, you can turn any number into a fraction by putting it over 1. So now, what would the reciprocal of that, what would the sine of alpha be? Well, that's 1 over 2 square root of 3. And then we're going to rationalize that to square root of 3 over 2 times 3, the number without the square root. So square root of 3 over 6. So you can see rationalizing is going to be really important, but using these reciprocal identities is pretty straightforward. Now, an identity that's a little more complicated here is the quotient identities. Did you know you can find the tangent of theta by taking sine divided by cosine? And that's a little bit tricky to understand. So we're going to do a quick little proof to show you why that works. Let's think about sine of theta and cosine of theta. So remember, sine is so opposite over hypotenuse, and cosine ca is adjacent over hypotenuse. Now, if we take sine of theta and we divide it by cosine of theta, well, that's going to be opposite over hypotenuse divided by adjacent over hypotenuse. Another way to write this is opposite over hypotenuse divided by adjacent over hypotenuse. Well, how do you divide fractions? You multiply by the reciprocal. Some people say keep, change, flip. So we're going to do opposite over hypotenuse times hypotenuse over adjacent. And the hypotenuses, one's on top and one's on bottom, they cancel. That gives me opposite over adjacent. But which of our trig functions is opposite over adjacent? TOA. Well, that is the tangent of theta. And so if you follow this string back, tangent of theta is sine over cosine. So our quotient identity tells us that the tangent of theta is equal to the sine of any angle divided by its cosine. And then if we just kind of think it through for a second, oh, hey, look at this. The cotangent is the upside down of the tangent, so it's just cosine over sine. Just flip it over. We're going to use these a lot towards the end of Unit 1. So knowing that tangent is sine over cosine is a really important thing. So let's see if we can use this to answer our next question here. We want to know, okay, this funny looking cursive B looking thing, this is the Greek letter beta. We want to know sine of beta and cosine of beta are these two things. What is tangent? Well, remember, tangent of beta is going to be sine divided by cosine. Well, that's just negative 1/2 divided by negative square root of 3 over 2. How do we divide? Keep, change, flip. That's negative 1/2 times -2 over the square root of 3. The negative times the negative will be positive. The 2's are going to cancel because one's on top and one's on bottom. So we have 1 over the square root of 3. And a quick rationalize here gives us square root of 3 over 3. And that is our final answer for tangent. Let's look at the other one. We want to find cotangent of theta given a cosine and a sine. So cotangent of theta is cosine over sine. Well, wait a minute here. What's square root of 5 divided by square root of 5? What's anything divided by itself? 1. And I have a positive divided by a negative, so our answer here will be -1.